So it's a real honor to give this inaugural lecture for Marilyn and Jim Simons. Marilyn and Jim Simons co-founded the foundation in 1994 in New York City, and the foundation exists to support basic or discovery-driven scientific research undertaken in the pursuit of understanding the phenomena of our world. So its goals are on the website. And one of the examples are that there, in the next couple of years, the Simons Observatory in the Chilean Atacama Desert will be operational to measure cosmic microwave background. What does that do? It'll address many of the fundamental questions of galactic astrophysics and explain the evolution of our universe from billions of years ago to today. I won't go into the details of dark matter. We've emerged from the dark room, at least in radiology, to CT scanners, but this is a very interesting and very powerful project. So the Simons Foundation also became interested in lung cancer screening. It started when they funded low-dose CT screening at Beth Israel Hospital, which is a hospital in New York City, shortly after the Lancet publication. We first learned about their interest because the radiologist there called us and said, well, how do we start a screening program? And those programs led to, as you see, first in New York City and then international collaboration of screening sites around the world that has allowed us to address many things. So for example, it allowed us to acquire enough. Is there somebody else talking? It allowed us to accumulate 31,567 participants in 2006 to look at the cure rate of all lung cancers diagnosed under annual screening, which was 80%. But the I-ELCAP approach also allows for looking at the independent components of diagnostic evaluation and treatment evaluation. Initially, we looked, using the I-ELCAP cohort, we looked at sublobar and lobectomy and how, which one had more, what the overall survival rate was under each approach. And you see that they were equivalent. And this was published by Dr. Al-Turki himself as the first author in 2014. So it predated the publications by 9 years of his randomized study. And think about it, 60 years ago, lobectomy was introduced, and it took until now to look at limited and sublobar resection. So we have to develop more efficient ways of evaluating treatment. So this article demonstrated the power of prospective data collection in the context of clinical care. And so we need to continually rethink and optimize all components of the diagnostic treatment paradigm, as you saw, as we develop better and better techniques. So that's why we started I-ELCAP, the Initiative for Early Lung Cancer Research on Treatment, which its research objectives include quality of life, comparison of treatment alternatives, staging of lung cancers, and other things that are related to lung cancer treatment. The Simons also provided the initial funding for I-ELCAP, the ongoing funding for I-ELCAP. And one of our latest papers that we are submitting is looking at surgery versus SBRT or radiation therapy for non-small cell lung cancers 20 millimeters or smaller in maximum diameter. There's been a lot of controversy, a lot of things written about it. So we decided to look at the database of I-ELCAP because it has long-term follow-up. So we have 525 patients that enrolled that were treated by surgery or SBRT between 1992 and 2021. And in I-ELCAP, which started in 2016, we have 590 patients treated with either surgery or SBRT. All of these are less than 20 millimeters in maximum diameter. So when you look at the lung cancer specific survival, whether it's the 5-year or 10-year, and actually we have much longer because we go out to 30 some months, but those survival times are equivalent. There's no statistical difference between surgery or SBRT. Now, when you go to all-cause mortality, then it's a little different because remember, these people had, the SBRT patients is considered the second line, not the optimal treatment, but second line treatment. And so they have typically many more comorbidities and other problems. And so you see that the all-cause mortality for radiotherapy versus surgery in I-ELCAP, which are the longer lines, and I-ELCAP, the shorter lines, they're different. But when you use propensity analysis to adjust for those differences in age, sex, comorbidities, we found that there was no significant difference between all-cause survival between surgery and SBRT. So this is the first cohort study to really demonstrate that. And we're submitting this for publication, and this was supported by the Simons Foundation. So as I said, we demonstrated, this article demonstrate the lung cancer specific survival is equivalent for the two, as well as the all-cause survival. And ELCAP is poised to do more of these analyses with data collected in the context of clinical care. So now, earlier, we had always been dreaming of artificial intelligence, or earlier it was called neural nets. And you recognize there, that's a quote from 1987 where I said, well, for patient management, neural nets, or I called it even artificial intelligence at that time, might play a role. But it took, and we actually reached out to Rome Labs, Booz Allen. We said, can't we use the latest technology for satellite imaging to look for lung cancers? And that resulted in several articles, including including an article in Business Week that said searching for lung cancers instead of tanks in 1994. But artificial intelligence took a long time to really, for computer technology to develop and for the mathematical approaches to develop. So it's only sometime after 2000, 2005 that it's really started to take off again. And we also looked at volumetrics. That has gotten more play than the artificial intelligence. Can you move to the next slide, please? So we've looked at artificial intelligence for nodules, for coronary artery calcifications and emphysema. As we all know, and we've heard today, and that there's a lot of opportunities to enhance the workflow and to leverage the power of the artificial intelligence. However, you need to have high quality data to really optimally use this. And so I wanted to introduce I-ELCAP AIRS, the automated image reading system project that we've just started. Can you advance to the next slide, please? Okay. We know that lung cancer is a leading killer, and that's already been discussed, almost 1 million deaths per year globally. And the cost is also, the economic cost of lung cancer is enormous. It's by far the most costly cancer. And as Jim Molshine, who's in the audience, said a long time ago that lung cancer screening promises big benefits, big reduction in cost. It would be the greatest single reduction of lung cancer mortality in the history of the war on cancer. But we need to make it available. And at the moment, most people at risk of lung cancer never get screened. So our approach, how do we fix that? We're going to talk about our approach. Think of it, screening is not a one-time test. You can have up to 30 or more annual repeat screenings through your lifetime if you start at age 50. But for successful implementation, you need to have qualified imaging centers. You need to have a management systems that everybody returns for their annual scan, and for follow-up, you need to have quality assurance processes, and you need to have radiologists, and all of the people here certainly understand all of those conditions. But we find there's a global shortage of radiologists, for one, not only worldwide, but also in the US. So our solution is to simplify radiology readings using AI to identify screenings which have no new findings and those that have no change. So we estimate, based on our data, that over 80% of the annual repeat scans are no change or no new findings. So that would considerably reduce the workload of the radiologist and allow them to focus on those scans that really need attention. So we are developing the open source automated image reading system that determines whether there's no change and no new nodules. This will act as a first read for annual low-dose CT scans so that radiologists don't need to spend time. And as we said, the majority of scans in an annual screening program are ones that have no change. So think about what could be accomplished if this is available. If sites around the world had access to this tool, it would dramatically reduce the burden on radiologists, especially in low and moderate income countries. It would allow for automation of the entire screening process by connecting it to a management system, such as the open source I-ELCAP management, the VA PALS I-ELCAP management system, or Screening Plus, and it would standardize the quality of the scan interpretations. Why I-ELCAP? Well, because we have the largest database of lung cancer screening with long-term follow-up, over 90,000 participants and over 300,000 CT scans collected from worldwide sites. We're leaders in lung cancer screening and leaders in the automated medical imaging sphere. And we've shown that we can find, from our initial article, we've looked at the cure rates in 2006, and then we've now updated the cure rates, and the cure rates have remained very high with lung cancer screening. If you come back for annual CT scans, the cure rate has remained at 80%, and we have many more participants at this point, so that the standard deviation of that is very small. So as we said, that could be the biggest reduction in lung cancer screening. And the team, you've seen the team here. You've seen David, Arted, Rowena, Rick Avila. The only one who's not here in person is Kyle Myers. Kyle Myers, but she's online. She's the former director of the Division of Imaging Diagnostics and Software Reliability in the FDA. So she now works, she's left the FDA and she works as a consultant, and she's guiding us so that we get FDA approval for this open source, which we will make freely available to the world and to all those who want to participate. So the Marilyn and Jim Simons Foundation now has funded this, starting in January of this year. They funded this to make this an open source software for the world. And so we thank them for making this accessible to us, making this possible to us, which while they reach with their observatory to the stars or beyond to the universe, we think it's like for us reaching to the stars to be able to provide this in a very, in a short time period. So we seek broad collaboration for this open source efforts and have already reached out to both industrial and academic partners. Thank you very much.